Have you ever stood outside on a clear night, looked up at the stars scattered across the darkness above you, and tried to count them? Maybe you got to 100, or if you were really determined, maybe a few hundred, before you gave up, overwhelmed by the sheer number of pinpricks of light stretching across the infinite black canvas of the sky. It's a humbling experience, isn't it? That moment when you realize that no matter how high you count, you're barely scratching the surface of what's actually up there. But here's the thing that's going to absolutely blow your mind. The stars you can see with your naked eye, all of them, every single one that you could ever count on the clearest night of your life, represent less than a fraction of a fraction of a fraction of the actual number of stars that exist in the universe. And today, we're going to explore that incomprehensible number together. We're going to take a journey that will fundamentally change how you see the cosmos and your place within it. If you've ever felt that pull of cosmic wonder, that deep curiosity about the scale and structure of the universe, then I'd love for you to join us on this exploration. If this video resonates with you, please consider liking it and subscribing to Cosmo Depth, because together we're uncovering the deepest mysteries of existence. Now, let's begin our journey into the staggering numbers that define our cosmos. When we talk about counting stars, we have to start with the most obvious question. How many can we actually see? If you find yourself in a location far from the light pollution of cities, somewhere truly dark where the Milky Way stretches across the sky like a river of milk, somewhere where you can see the zodiacal light and the faintest stars of the zodiacal constellations, you might be able to see somewhere between 3,000 and 5,000 stars with your naked eye. That's it. That's the entire visible universe from your perspective, standing on the surface of Earth with nothing but your eyes and the natural light-gathering ability of the human pupil. 5,000 stars. It sounds like a lot, and in the context of human experience, it absolutely is. If you tried to count them one by one, speaking each number aloud, it would take you hours. If you tried to count them at a rate of 1 per second without stopping, it would take you over an hour and a half of continuous counting. That's a significant amount of time, a substantial number by any human measure. But in the context of the actual universe, 5,000 is so infinitesimally small that it barely registers as a meaningful number. It's like trying to count the grains of sand on a single beach when there are millions of beaches on Earth, and then realizing that there are also countless more beaches on other planets, and then discovering that there are more beaches in other galaxies than there are atoms in all the sand on all the beaches on Earth. The scale just keeps expanding, layer upon layer, until your mind starts to struggle with the very concept of magnitude itself. The reason we can only see such a small number of stars is fundamentally about distance and the limitations of human vision. Stars are, with very few exceptions, incredibly far away. The closest star to our Sun, aside from the Sun itself, is Proxima Centauri, and it's over 4 light-years away. That means that the light we see from Proxima Centauri today left that star over 4 years ago. It's been traveling through the vacuum of space for 4 years, crossing the vast emptiness between the stars just to reach our eyes, and Proxima Centauri is our nearest neighbor, our closest stellar companion in the cosmic neighborhood. Most stars are vastly, incomprehensibly more distant. The next closest star system, Alpha Centauri is over 4.3 light-years away. Sirius, the brightest star in our night sky, is about 8.6 light-years away. Betelgeuse, the red supergiant that marks the shoulder of Orion, is over 600 light-years away. And these are just the nearby stars, the ones that are close enough to be among the brightest in our sky. Most stars are much, much further away. The faintest stars we can see with our naked eye are hundreds of light-years away, and the vast majority of stars in the universe are too faint and too distant for us to see without telescopes. The human eye can only detect light down to a certain threshold of brightness. This threshold is determined by the sensitivity of the rod cells in the retina, the light-sensitive cells that allow us to see in dim conditions. Stars that are far away appear dimmer because the light they emit spreads out as it travels through space, following what's known as the inverse square law. If you double your distance from a light source, the light you receive decreases by a factor of 4. If you triple your distance, it decreases by a factor of 9, and so on. This means that stars that are far away appear much dimmer than stars that are close. Eventually, stars become so dim that our eyes simply cannot detect them anymore. They're still there, shining their light across the cosmos, still burning with the same intensity they always have, but that light is too faint by the time it reaches us for our biological vision to register it. It's below the threshold of human perception. This is why, for the vast majority of human history, people thought there were only a few thousand stars in the sky. It wasn't that there were only a few thousand stars, it was that we could only see a few thousand stars. The universe was full of countless more, but they were invisible to us, hidden beyond the threshold of human perception, locked away in the darkness, waiting for us to develop the technology to see them. Ancient astronomers did their best with what they had, mapping the constellations and tracking the motions of the visible stars, but they had no idea of the true scale of the universe. Then came the telescope. In the early 1600s, Galileo Galilei, an Italian astronomer and physicist, pointed a primitive telescope at the night sky, and everything changed. His telescope was crude by modern standards, with a magnification of only about 20 times and a field of view so narrow that you could barely see anything at all. But it was revolutionary. Suddenly, stars that had been invisible to the naked eye became visible. The telescope could gather more light than the human eye, concentrating it and magnifying it, allowing us to see fainter and fainter stars. When Galileo pointed his telescope at the Milky Way, he was shocked to discover that it wasn't a diffuse cloud of light, as it appeared to the naked eye, but rather a vast collection of individual stars, so numerous that they blended together into a milky band across the sky when viewed without magnification. From that moment on, astronomers began to realize that the universe was far, far larger than anyone had previously imagined. But even with telescopes, we were still limited. We could see more stars, certainly, but we still couldn't see all of them. The universe was still mostly hidden from us, still mostly dark, still mostly unknown. It wasn't until the 20th century, with the advent of increasingly powerful telescopes and eventually space-based observatories that could escape the distorting effects of Earth's atmosphere, that we began to get a true sense of just how many stars were actually out there. The development of photography in the 19th century also helped, allowing astronomers to record the positions of stars and to count them more systematically. Now, let's talk about our home galaxy, the Milky Way. The Milky Way is a spiral galaxy, a vast rotating disk of stars, gas, and dust held together by gravity. It's difficult to overstate just how large the Milky Way is. Imagine a disk of stars so vast that if you tried to travel across it at the speed of light, the fastest speed possible in the universe, it would take you over 100,000 years to cross from one side to the other. 100,000 years. That's longer than the entire history of human civilization. That's longer than anatomically modern humans have even existed on Earth. We've only been around for about 200,000 years, and for most of that time, we were hunter-gatherers without written language or complex technology. And yet, the Milky Way is so large that it would take light 100,000 years just to cross its disk. That's just the width of the disk. The Milky Way is also incredibly thick, with a central bulge of stars surrounding a supermassive black hole at the very center. This central black hole, called Sagittarius, a star, has a mass of about 4 million times the mass of our Sun. It's a region of space where gravity is so intense that nothing, not even light, can escape if it gets too close. The entire structure is rotating, with stars orbiting around the galactic center at different speeds depending on their distance from the center. Our Sun is located about 26,000 light-years from the galactic center, in a relatively quiet region of the galaxy that we call the Orion Spur. We're not at the center of the galaxy, and we're not at the edge. We're somewhere in the middle, in a fairly typical location, orbiting the galactic center once every 230 million years or so. That means that since the dinosaurs went extinct, our Sun has completed less than a single orbit around the galactic center. We're moving through space at an incredible speed, but the distances are so vast that even at light speed, it takes an enormous amount of time to complete a single orbit. Now, how many stars are in the Milky Way? This is a question that astronomers have been trying to answer for centuries, and the answer has changed dramatically as our tools and techniques have improved. In the early 20th century, astronomers estimated that the Milky Way contained somewhere around 100 billion stars. That was a staggering number at the time, and it seemed almost impossibly large. The idea that there were 100 billion stars, each one potentially a sun like ours, was almost too much for the human mind to comprehend. But as our telescopes improved and our understanding of stellar populations grew more sophisticated, we realized that our estimates had been too low. By the mid-20th century, the estimate had been revised upward to around 200 billion stars. 200 billion. That's 2 followed by 11 zeros. It's a number so large that it's almost meaningless to the human mind. If you tried to count to 200 billion, counting one number per second without stopping to sleep or eat, without taking any breaks whatsoever, it would take you over 6,000 years. And that's just the stars in our galaxy. There are galaxies beyond ours, many of them containing even more stars than the Milky Way. The precision of these estimates has improved dramatically with modern technology, but the basic order of magnitude has remained consistent. Different methods of estimation, from star counts in sample regions to spectroscopic analysis of galactic light, all converge on a similar number, which gives us confidence that our estimates are in the right ballpark. But before we talk about those other galaxies, let's really try to grasp what 200 billion stars means. Imagine, if you will, that every single person on Earth, all 8 billion of us, was given the task of counting stars. And imagine that each person was given 25 stars to count. That would account for all 200 billion stars in the Milky Way. But here's the thing. If you gave each person on Earth 25 stars to count, and they all started counting at the same time, and they all counted at a rate of 1 star per second, it would still take them over 8 seconds to finish. 8 seconds to count all the stars in the Milky Way if every human on Earth was counting simultaneously. That's how many stars we're talking about. It's a number that defies intuition, that resists comprehension, that pushes the limits of what the human mind can truly grasp. And remember, this is just one galaxy. There are billions of other galaxies out there, many of them containing comparable or even greater numbers of stars. The sheer scale of it all is almost too much to contemplate. When you really think about it, when you really try to grasp the magnitude of this number, it can be almost overwhelming. It can make you feel small, insignificant, lost in an incomprehensibly vast cosmos. And yet, at the same time, it can be profoundly beautiful and awe-inspiring. How did astronomers arrive at this estimate of 200 billion stars? Well, they didn't count them all individually. That would be impossible, even with the most advanced technology we have today. Instead, they used statistical sampling and extrapolation. They would observe a small region of the sky in great detail, using powerful telescopes to count the stars in that region, and then multiply that number by the total area of the sky to estimate the total number of stars in the galaxy. They would also use information about stellar populations, the distribution of different types of stars, and the structure of the galaxy to refine their estimates. They would look at the brightness distribution of stars, understanding that fainter stars are more numerous than bright stars, and use that information to estimate how many faint stars exist beyond the reach of their telescopes. This is based on the Hertzsprung-Russell diagram, a plot of stellar brightness versus temperature that reveals the fundamental properties of stars and their distribution in the galaxy. As telescopes improved and as we launched space-based observatories like the Hubble Space Telescope, which could escape the distorting effects of Earth's atmosphere, we were able to observe fainter and fainter stars, which allowed us to refine our estimates even further. Today, with the Gaia satellite, which has mapped over 1 billion stars in our galaxy with unprecedented precision, measuring their positions, distances, and motions with extraordinary accuracy, we have a much more detailed picture of the stellar population of the Milky Way. And while the estimate of 200 billion stars remains a good round number, the actual count is likely somewhere between 100 billion and 400 billion, depending on how you define a star and what size threshold you use. Some estimates go even higher, suggesting that the Milky Way might contain up to 400 billion stars or more. The uncertainty reflects the difficulty of the task and the various methodologies that astronomers use to arrive at their estimates. But here's where things get really interesting. The Milky Way is not unique. It's not even particularly special in many ways. In fact, the Milky Way is a fairly large galaxy, but it's not the largest galaxy in the observable universe. There are galaxies out there that are much, much larger than the Milky Way, galaxies that contain trillions of stars. The galaxy IC 1101, for example, is an ultra-giant elliptical galaxy that may contain up to 100 trillion stars. That's 100 million times more stars than the Milky Way. Imagine that, 100 million times more stars. That's a number so large that it's almost impossible to comprehend. And there are also galaxies that are much smaller than the Milky Way. Dwarf galaxies that contain only a few billion stars, or even a few 100 million stars. But the key point is that there are a lot of galaxies. A lot. And I mean a lot in a way that's almost incomprehensible. The sheer number of galaxies in the observable universe is staggering, and when you multiply that by the average number of stars per galaxy, you get a total that is almost impossible to fathom. The diversity of galaxy types is also remarkable, ranging from spiral galaxies like the Milky Way to elliptical galaxies to irregular galaxies to lenticular galaxies, each with its own characteristics and its own population of stars. For most of human history, we didn't even know that other galaxies existed. We thought the Milky Way was the entire universe. We thought that everything that existed was contained within this one vast disk of stars, that the Milky Way was the totality of creation. But in the early 20th century, astronomers began to notice fuzzy patches of light in the sky that didn't seem to fit into any of the known categories of celestial objects. They called them nebulae, which is Latin for clouds. Some astronomers thought these nebulae were clouds of gas within the Milky Way, perhaps regions where new stars were being born. Others thought they might be separate island universes, entirely separate galaxies beyond the Milky Way, vast collections of stars so far away that they appeared as fuzzy blurs even through the most powerful telescopes of the time. This became known as the Great Debate, and it raged among astronomers for decades. The question was simple but profound. Are these nebulae part of our galaxy, or are they separate galaxies entirely? It was a question that would fundamentally change our understanding of the universe, and the answer would not come easily. The debate was so contentious that it divided the astronomical community, with prominent astronomers on both sides of the issue. The answer came in the 1920s when Edwin Hubble, using the most powerful telescope in the world at the time, the 100-inch Hooker telescope on Mount Wilson in California, was able to resolve individual stars in the Andromeda Nebula. He showed that Andromeda was so far away that it couldn't possibly be part of the Milky Way. The distances involved were so vast that Andromeda had to be a separate galaxy, a vast collection of billions of stars located far beyond our own galaxy. This discovery fundamentally changed our understanding of the universe. Suddenly, the universe was vastly larger than anyone had previously imagined. The Milky Way, which had seemed so impossibly large, was revealed to be just one galaxy among many. And if there was one galaxy beyond the Milky Way, there had to be others, many others. The universe, it turned out, was not a single island of stars, but an archipelago, a vast collection of islands separated by the emptiness of space. Hubble's discovery was one of the most important scientific breakthroughs of the 20th century, and it fundamentally reshaped our understanding of our place in the cosmos. It was a moment of profound realization, a moment when humanity understood that we were even smaller and more insignificant than we had previously thought. In the decades that followed, astronomers began to map out the distribution of galaxies in the universe. They discovered that galaxies were not uniformly distributed throughout space. Instead, they were clustered together, forming groups and clusters of galaxies, which were themselves part of larger superclusters. Our Milky Way is part of a group called the Local Group, which contains around 80 galaxies, with the Milky Way and Andromeda being the two largest members. The Local Group is itself part of a larger structure called the Virgo supercluster, which contains tens of thousands of galaxies. And the Virgo supercluster is just one supercluster among many. The universe, it turned out, had a structure that was far more complex and far more vast than anyone had imagined. It was like discovering that what you thought was a single forest was actually a vast continent covered with forests, with mountains and valleys and rivers, all organized in a complex and intricate pattern. This hierarchical structure, with galaxies grouped into clusters, and clusters grouped into superclusters, and superclusters arranged in a cosmic web, is one of the most important discoveries in modern cosmology. The cosmic web, as it's called, shows that the universe has a structure that resembles a vast network of filaments and voids, with galaxies concentrated along the filaments and vast empty voids between them. But the real breakthrough in understanding the total number of galaxies came in 1995, when the Hubble Space Telescope, orbiting high above Earth's atmosphere, pointed at a tiny patch of sky, a region so small that it would take 1,000 of these patches to cover the area of the full moon. The region was chosen almost at random, with no particular reason to think it would be special. In fact, the astronomers deliberately chose a region that appeared to be almost completely empty, with very few visible galaxies. They wanted to see what was in the apparently empty regions of space. But when the Hubble team looked at the images that came back, they were stunned. The tiny patch of sky, which appeared to be almost completely empty to ground-based telescopes, was absolutely packed with galaxies. Thousands of galaxies, each one containing billions or trillions of stars. This became known as the Hubble Deep Field, and it fundamentally changed our understanding of the universe's scale. It was like looking at what you thought was an empty field and discovering that it was actually filled with an invisible city, with buildings and streets and countless inhabitants, all hidden from view until you looked closely enough. The Hubble Deep Field has been followed by even deeper observations, including the Hubble Ultra Deep Field and the Hubble Extreme Deep Field, each one revealing even more galaxies in even smaller patches of sky. These observations have been absolutely transformative in our understanding of the universe. If this tiny patch of sky, which represents only 1/1,000,000th of the total area of the sky, contained thousands of galaxies, then the entire observable universe must contain billions of galaxies. Astronomers did the math and came up with an estimate. There are approximately 2 trillion galaxies in the observable universe. 2 trillion. That's 2 followed by 12 zeros. It's a number so large that it dwarfs the 200 billion stars in the Milky Way. It's a number so large that it's difficult to even comprehend what it means. If you tried to count to 2 trillion, counting one number per second without stopping, it would take you over 63,000 years. And that's just counting the galaxies, not the stars within them. And remember, Each one of those 2 trillion galaxies contains billions or trillions of stars. The numbers start to become almost meaningless at this scale. They exceed the capacity of the human mind to truly comprehend them. We can understand the numbers intellectually. We can manipulate them mathematically, but we cannot truly visualize what they mean. The human mind simply did not evolve to deal with numbers of this magnitude. Our brains evolved to deal with small numbers, the numbers that were relevant to our survival as a species. We can visualize a few, we can visualize dozens, we can even visualize hundreds or thousands. But billions and trillions are beyond our intuitive grasp. This is one of the great challenges of modern cosmology. Trying to communicate the true scale of the universe to people who have no intuitive framework for understanding such large numbers. Now, let's do the final calculation. If there are 2 trillion galaxies in the observable universe, and each galaxy contains, on average, around 200 billion stars, then the total number of stars in the observable universe is approximately 400 billion trillion. Or, to put it another way, septillion. That's a 4 followed by 24 zeros. That's 400 billion trillion individual suns, each one potentially with its own planetary system, each one potentially with its own worlds where life might exist. It's a number so vast that it makes the entire human species, all 8 billion of us, seem utterly insignificant. If you took every human being who has ever lived, every person who has ever walked on Earth, every person who has ever drawn breath and looked up at the stars, and you multiplied that number by the number of stars in the observable universe, you would still have fewer stars than there are atoms in a single grain of sand. The scale is almost incomprehensible. When you really think about it, when you really try to grasp the magnitude of this number, it can be almost overwhelming. It can make you feel small, insignificant, lost in an incomprehensibly vast cosmos. And yet, at the same time, it can be profoundly beautiful and awe-inspiring. There is something deeply moving about contemplating the vastness of the universe and our place within it. But wait, there's more. This number, 400 billion trillion, is based on the observable universe. The observable universe is the part of the universe that we can see, the part from which light has had time to reach us since the Big Bang, roughly 13.8 billion years ago. But the universe is almost certainly much larger than the observable universe. In fact, current cosmological theory suggests that the universe might be infinite, or at least vastly larger than the observable universe. If the universe is indeed infinite, then the total number of stars might also be infinite. There might be infinitely many stars scattered throughout infinitely vast reaches of space, far beyond the cosmic horizon that defines the edge of the observable universe. There might be infinite galaxies, infinite worlds, infinite possibilities. The very concept of infinity is difficult for the human mind to grasp. We can talk about it mathematically, we can manipulate it with symbols and equations, but we cannot truly visualize it. Infinity is not a number, it's a concept, an idea, a limit that can be approached but never reached. The implications of an infinite universe are staggering. It means that somewhere out there, beyond the edge of the observable universe, there could be countless other versions of our galaxy, other versions of Earth, other versions of us. It means that the universe is not just vast, it is incomprehensibly, unimaginably vast. how do we actually know these numbers? How do astronomers arrive at these estimates? Well, it's a combination of observation, theory, and statistical inference. When astronomers observe distant galaxies, they can measure their brightness and their distance. From the brightness and distance, they can infer how many stars the galaxy contains. They can also observe the spectrum of light coming from a galaxy, which tells them about the types of stars in that galaxy and their distribution. By combining all of this information, they can estimate the total number of stars in a galaxy. Then, by observing a representative sample of galaxies and measuring their properties, they can estimate the average number of stars per galaxy. Finally, by counting the number of galaxies in a representative sample of the sky and extrapolating to the entire sky, they can estimate the total number of galaxies in the observable universe. Multiply the number of galaxies by the average number of stars per galaxy, and you get the total number of stars. It's a process that involves careful observation, sophisticated analysis, and a good understanding of statistics and probability. The process is not perfect, and there are many sources of uncertainty and potential error. But it's the best method we have, and it has been refined over decades of careful work by thousands of astronomers around the world. The consistency of results from different methods gives us confidence that our estimates are reasonably accurate. Of course, these are estimates, and they come with significant uncertainties. The actual number of stars in the observable universe could be somewhat higher or somewhat lower than 400 billion trillion, depending on various assumptions about galaxy sizes, stellar populations, and the definition of what counts as a star. Some estimates suggest that the number could be as high as 1 septillion or even higher, but the order of magnitude is correct. We're talking about hundreds of billions of trillions of stars. We're talking about a number so large that it's almost impossible to comprehend. And this number is constantly being refined as our observations improve and our understanding of the universe deepens. As we build more powerful telescopes and develop more sophisticated techniques for analyzing astronomical data, our estimates will become more accurate and more precise. The estimates will likely change as we learn more, but the fundamental conclusion will remain the same. The universe contains an almost incomprehensibly large number of stars. One of the most important tools for counting stars in recent years has been the Gaia satellite, launched by the European Space Agency in 2013. Gaia is a space telescope designed specifically to map the positions, distances, and motions of stars in our galaxy. It has created the most detailed three-dimensional map of the Milky Way ever made, cataloging the positions of over 1 billion stars with unprecedented precision. This has allowed astronomers to refine their estimates of the total number of stars in the Milky Way and to better understand the structure and dynamics of our galaxy. It has revealed the presence of stellar streams, the remnants of dwarf galaxies that have been torn apart by the Milky Way's gravity. It has shown us the distribution of different types of stars throughout the galaxy. It has given us a much clearer picture of what our galaxy looks like and how it's organized. But Gaia is just one tool among many. Ground-based telescopes continue to observe distant galaxies. Space-based observatories like the James Webb Space Telescope are peering deeper into space and further back in time than ever before. revealing galaxies that existed when the universe was only a few 100 million years old. And new surveys are constantly discovering new galaxies and refining our estimates of their properties. The James Webb Space Telescope, in particular, has already made remarkable discoveries, revealing galaxies that are far more massive and far more mature than we expected them to be at such early times in the universe's history. This suggests that our models of galaxy formation may need to be revised, which could have implications for our estimates of the total number of stars. Now, let's take a step back and think about what these numbers mean. 400 billion trillion stars. It's a number that's almost impossible to visualize, almost impossible to comprehend. But let's try to put it into perspective. If you were to represent each star as a single grain of sand, then all the stars in the observable universe would fill a volume of space that would be larger than all the oceans on Earth combined. In fact, it would be vastly larger. It would be so large that if you tried to count the grains of sand, 1 per second, it would take you longer than the age of the universe to finish. The scale is almost incomprehensible. And yet, despite this almost infinite number of stars, the universe is mostly empty space. The vast majority of the universe is nothing. It's a vacuum, a void, a nothingness that stretches between the stars and galaxies. If you were to scale down the universe so that the sun was the size of a grain of sand, then the nearest star would be about a mile away. The Milky Way would be about 100,000 miles across, and the nearest galaxy, Andromeda, would be about 2 million miles away. Even at this scale, the universe would be mostly empty. The stars and galaxies would be tiny specks scattered through an almost incomprehensibly vast emptiness. The universe is not a crowded place. It is a place of profound isolation and emptiness, with islands of light separated by vast oceans of darkness. This brings us to one of the most profound questions in science. If there are so many stars, and if even a small fraction of those stars have planets, and if even a small fraction of those planets are habitable, then where is everybody? This is the Fermi paradox, named after the physicist Enrico Fermi, who famously asked this question during a lunch conversation in 1950. If the universe is so vast and so full of stars, then statistically, there should be countless civilizations out there. There should be radio signals, space probes, evidence of extraterrestrial intelligence. But we see nothing. The universe appears to be silent. We are, as far as we know, alone. Or at least, we haven't found any evidence of anyone else yet. The silence of the universe is one of the great mysteries of science, and it raises profound questions about the nature of life and intelligence in the cosmos. It's a question that has haunted scientists and philosophers for decades, and it remains one of the most important unsolved problems in astrobiology. There are many possible explanations for this paradox. One is that intelligent life is extremely rare, far rarer than we might expect based on the sheer number of stars. Perhaps the conditions necessary for life to arise are more stringent than we think. Perhaps the probability of life arising on a habitable planet is much lower than we estimate. Perhaps intelligent life is even rarer, requiring a specific set of circumstances that are almost never met. Another explanation is that intelligent civilizations tend to destroy themselves before they develop the technology to communicate across interstellar distances. Perhaps most civilizations that reach a certain level of technological development end up destroying themselves through war, environmental collapse, or some other catastrophe. Another explanation is that intelligent life does exist out there, but it's so far away that we can't detect it, or it's deliberately hiding from us. Perhaps advanced civilizations have learned to keep quiet, to avoid drawing attention to themselves. Or perhaps intelligent life uses communication methods that we haven't thought to look for. The Fermi paradox remains one of the great unsolved mysteries of science, and the answer to it will have profound implications for our understanding of our place in the universe. But let's think about the sheer probability of life. If there are 400 billion trillion stars in the observable universe, and let's say that 1% of those stars have planetary systems, that would be 4 billion trillion stars with planets. And let's say that 1% of those planetary systems have planets in the habitable zone, where liquid water could exist on the surface. That would be 40 billion trillion potentially habitable planets. And let's say that 1% of those planets actually develop life. That would be 400 billion trillion planets with life. That's more planets with life than there are stars in the observable universe. The sheer numbers suggest that life should be common, that the universe should be teeming with it. And yet, we have no confirmed evidence of any life beyond Earth. We have no signals from space, no visits from aliens, no evidence of any civilization beyond our own. It's one of the great mysteries of science, and it raises profound questions about our own existence and our place in the cosmos. Perhaps life is far rarer than these calculations suggest. Perhaps the conditions necessary for life are more specific and more difficult to achieve than we realize. Or perhaps we're simply not looking in the right way, not listening for the right signals, not recognizing the signs of life when we encounter them. This raises a profound question about our own existence. We are made of stardust, literally. The atoms that make up our bodies were forged in the cores of stars billions of years ago. When those stars died, they scattered their atoms across space. Those atoms eventually coalesced to form new stars and planets, including our Sun and Earth. The carbon in our bodies, the oxygen we breathe, the iron in our blood, all of it came from stars. We are not separate from the universe. We are a part of it. We are the universe experiencing itself, becoming aware of itself, contemplating itself. In a very real sense, the universe is looking at itself through our eyes. We are made of the same material as the stars. We are connected to them across the vast distances of space and time. We are one with the universe. This is not just a poetic metaphor. It's a literal truth. The atoms in your body were created in the cores of stars that lived and died billions of years ago. You are made of stardust. You are made of the remnants of ancient suns. You are a child of the stars. Every atom in your body has a history that stretches back to the beginning of the universe. And when we look up at the night sky and see those 5,000 stars that are visible to the naked eye, we're seeing just the tiniest fraction of the total. We're seeing just the closest, brightest stars, the ones whose light is strong enough to reach our eyes after traveling across the vast distances of space. But beyond those visible stars, there are billions and billions more, stretching out into the darkness, beyond the reach of our eyes, beyond the reach of our telescopes, beyond the reach of our current understanding. The universe is vast beyond measure, deep beyond comprehension, and we are just beginning to understand its true scale. Every time we look up at the night sky, we're looking at a tiny window into an almost incomprehensibly vast cosmos. We're looking at light that has traveled for years, decades, centuries, or even millions of years to reach our eyes. We're looking at the past. We're looking at history written in light. The light from the most distant galaxies we can see has been traveling for over 13 billion years to reach us, carrying with it information about the universe as it was when it was very young. The history of astronomy is, in many ways, a history of realizing how small we are. For thousands of years, humans believed that the Earth was the center of the universe, that everything revolved around us. We were special, we were important, we were the purpose of creation. Then came Copernicus and the realization that the Earth orbits the Sun, not the other way around. We were no longer at the center. We were just another planet, orbiting an ordinary star. Then came the discovery that the Sun is just one star among billions in the Milky Way, and that the Milky Way is just one galaxy among billions in the observable universe. Each discovery has pushed us further and further from the center, has made us smaller and smaller in the grand scheme of things, and yet, paradoxically, each discovery has also made us more significant, because we are the part of the universe that can understand the universe. We are the part of the universe that can contemplate its own existence. We are the part of the universe that can count the stars. We are the universe becoming aware of itself. This is perhaps the greatest significance of all, that we are the part of the universe capable of understanding it, capable of asking questions about its nature and structure, capable of seeking answers to the deepest mysteries of existence. Looking forward, our understanding of the number of stars in the universe will continue to improve. New telescopes, both ground-based and space-based, will allow us to observe fainter and more distant galaxies. New techniques in data analysis and machine learning will allow us to extract more information from the observations we make. The James Webb Space Telescope, launched in 2021, is already providing unprecedented views of the distant universe, revealing galaxies that existed when the universe was only a few 100 million years old. Future telescopes, like the extremely large telescope currently under construction in Chile, will be even more powerful, allowing us to see even fainter and more distant objects. The Square Kilometre Array, a massive radio telescope project that will span multiple continents, will allow us to detect faint radio signals from distant galaxies. These new tools will revolutionize our understanding of the universe and will allow us to refine our estimates of the number of stars even further. They may also help us in our search for extraterrestrial life, allowing us to detect signals from distant civilizations or to identify planets with signs of biological activity. The future of astronomy is bright, and the discoveries that await us will undoubtedly transform our understanding of the universe and our place within it. But even as our technology improves and our understanding deepens, there will always be limits to what we can observe. The observable universe has a horizon, a boundary beyond which we cannot see, because light from beyond that boundary hasn't had time to reach us yet. And beyond that horizon There may be vast regions of space that we will never be able to observe, simply because the universe is expanding faster than light can travel. So, while we may refine our estimates of the number of stars in the observable universe, we may never know the true total number of stars that exist. We may never know the true scale of the universe. And perhaps that's fitting. Perhaps it's appropriate that the universe retains some mystery, some unknowability, some aspect that resists our attempts to fully comprehend it. The universe is vast, it is deep, it is full of wonder and mystery, and we are just beginning to understand it. The quest to understand the universe, to count its stars, to measure its dimensions, is one of humanity's noblest endeavors. It speaks to something deep within us, a desire to understand our place in the cosmos, to connect with something greater than ourselves. This quest has driven human civilization forward for thousands of years, and it will continue to drive us forward into the future. In the end, the question of how many stars exist in the universe is not just a question about numbers. It's a question about our place in the cosmos, about our significance and insignificance, about our connection to the vast and ancient universe that surrounds us. When we contemplate the 400 billion trillion stars scattered throughout space, we're not just contemplating a number. We're contemplating the scale of existence itself, the immensity of creation, the depth of mystery that lies beyond our current understanding. We are contemplating the possibility that somewhere out there, on one of those billions of trillions of planets, there might be other beings looking up at their own night sky, wondering the same questions that we wonder, contemplating the same mysteries that we contemplate. We are contemplating the fact that we are made of the same atoms as those distant stars, that we are connected to them across the vast distances of space and time, that we are, in a very real sense, one with the universe. We are stardust that has become conscious, that has become aware, that has developed the ability to understand the universe from which it came. We are the universe experiencing itself, understanding itself, marveling at itself. So the next time you find yourself under a dark sky, looking up at those 5,000 visible stars, remember that you're seeing just the tiniest fraction of what's actually out there. Remember that beyond those visible stars, there are billions and billions more. And beyond those, there are billions and billions of galaxies, each containing billions and billions of stars. Remember that the universe is vast beyond measure, deep beyond comprehension, and that we are just beginning to understand its true scale. Remember that you are made of stardust, that you are connected to every star in the sky, that you are a part of this vast and ancient cosmos. Remember that the universe is full of wonder, full of mystery, full of possibilities that we are only beginning to explore. And remember that the question of how many stars exist in the universe is ultimately a question about ourselves, about our place in the cosmos, about our connection to the vast and infinite universe that surrounds us. The universe is calling to us, inviting us to explore, to question, to wonder. And that perhaps is the most important number of all, the infinite potential for discovery that lies ahead of us. Thank you for joining us on this cosmic journey. If you found this exploration of the universe's stars fascinating, please like this video and subscribe to Cosmo Depth for more deep dives into the mysteries of the cosmos. The universe is waiting to be understood, and together we can continue to uncover its secrets. The stars are calling, and we must answer.